So good morning, my name is Andrew Betts, I'm from the Financial Times. At the FT, we built an HTML5 app about 18 months ago. With just web technologies, the great thing about it is that you can use it without an internet connection. There's no native code, it's just a website that you're using in your browser, but you can type our web address in and we'll load a web page for you which you can navigate without any connection to the web. I'm going to talk about why that's important, how offline technologies affect the websites that we make today and will affect the websites we build tomorrow, and how to make use of offline technologies in what you're building. I think before I start, a little bit of historical context is required. The FT has actually been doing this kind of thing for a long time. We produced our first news reading app in 1888. And we call it a newspaper. And that might sound a bit glib, but actually, when you think about it, a newspaper is actually a really good news-reading client. What do we get from a newspaper? Well, if I were to make a list of all the things I want from my news-reading client and write them down, and then cross out those things that I can't get from a newspaper, I actually do pretty well. It starts up very quickly. It works offline. It has no concept of working online, but nevertheless, I don't need an internet connection to read a newspaper. I can read it in bright sunlight. It lasts a really long time, as long as I'm not in the rain. I can bookmark and share stuff. I need to use scissors, but nevertheless, that works. I can circle stories I'm interested in. I can write in the margins. When I'm finished with the newspaper, I can give it to someone else. All of these are things which you don't necessarily get by default when you build a digital solution. So we need to be aware of these features which we may be delivering without really thinking about it. And when the web came along and newspapers started putting content online digitally, we got a whole load of new stuff. We got the ability to read the content in the dark, update it in real time, deliver it electronically. We were able to search, personalize that content to the end user, and deep link directly to particular pieces of content. But we also lost a whole load of stuff that we could do with a newspaper. The web 1.0 of the early 2000s was never going to be a replacement for reading a physical newspaper in print. And I think that goes some way to explaining why, as a business, we still print about 1/3 of a million newspapers every day. So then I suppose we need to talk about apps, because native apps became very popular with publishers. And one of the reasons for that is that with a native app, you can get closer to the kind of package of content that you deliver with a physical newspaper. With the rise of things like Google Reader and aggregation technologies, publishers increasingly get disintermediated. You get consumers consuming content from a wide range of publishers, and they're consuming individual pieces of content. They're not interested anymore in our editing. They're not interested in the aggregation that we do, the value that we add by bringing stories together. And publishers see apps, or saw apps, potentially as a way of fighting that and delivering a neat package of content that contains a lot of stuff in one neat bundle. But at the same time, apps don't actually deliver all of the features that we want to provide users in our news reading experience. And some of these actually could be impossible to deliver on certain proprietary technology platforms. So my sort of mantra that drives our choice of technology is that we need to care about supporting our existing features as much as we do about getting new ones. And that's one of the reasons why we've chosen HTML5. Because with HTML5, we can hopefully deliver on the vast majority of this stuff. And what we can't do today, we can work with the community to make sure that we can do tomorrow, including maybe good battery life eventually. And HTML5, often in business, is seen as an alternative to building native apps, because the two are often considered to be two options to deliver the same thing. But actually, HTML5 has nothing to do with mobile. and it's not an alternative, or not just an alternative to building native apps. It's actually just the next generation of web technologies and a way of making better websites. And we can use HTML5 to improve any website, whether it be a mobile website, a desktop website, or frankly a website that we don't care what device you're using to access. So, on that theme, we need to start thinking more and more about losing the constraints, not putting specific technology solutions into boxes and saying, this is our solution for this platform, or this set of constraints. If we can deliver a solution that where we don't care how you access it, we don't care where you are, we don't care what device you're using, then we can actually open up our audience to people we never even thought of. So today, we care about tablets, phones, desktops, and laptops. 5 years ago, we only cared about half of those, only desktops and laptops. So in 5 years' time, maybe we'll care about even more of these kind of devices that we can use that have web browsers that can consume our content. TVs, games consoles, in-car and in-flight screens, billboards, kiosks, and e-ink readers. So with all of this kind of stuff in mind, we have created the FT web app as it stands today, and that's not in any way a full solution to all of this, but we see it as a step on the road in the right direction. So I have a quick demo of the app for those people who haven't actually seen it. This is a little bit of a glossy marketing video, but it's only a minute long, so bear with me. Everything you see in this video is in a browser. You can do this just by navigating to a URL in your web browser. So we have the slider, which enables you to move from one section to another laterally. Obviously, you can't do this in a browser. This is just illustration. We make certain customizations to the interface based on your platform. We're actually doing less and less of that now because we feel like from one platform to another, you should just get a consistent experience of the FT, and it shouldn't feel like Android or iOS. It should just feel like the FT brand. And whilst you're navigating through the app, we're constantly downloading content in the background. And that's the key to making the app work offline. If we go into airplane mode, as we're doing now, we can now navigate to a story we haven't been to yet, and it will still load. Let's see, what are we doing now? So all of this content that we're now looking at is content that's been downloaded in the background whilst we've been viewing other stories. Even these really big images, even the markets data, we can download all of this content, we can store it locally on the device so that we can display it when we don't have an internet connection. And when we go back online, as we do now on the playbook, the app can detect that we once again have an internet connection, and it can update itself. And this app is not specific to tablets. This is exactly the same app, exactly the same URL loaded on a phone, and we can use responsive design to make the interface fit that device. So, I like to use the phrase one app, million devices, and I think the objective here is that ideally we want to stick with one single solution, and as new devices come along that we want to support, we will optimize that app and hopefully have an easier time with every new device that we want to add. So, I'm going to spend the rest of the talk specifically on offline and the particular challenges of making the app work without a connection, because that's one of the most difficult things that we had to deal with in the build. And over the last couple of years, I guess, as web developers, we've encountered or we've created a number of best practice techniques, libraries, frameworks to allow us to do things like dependency management or analytics or tracking login state in a way that is achieves a very high standard without us really having to think about it. And some of these off-the-shelf, ready-made solutions start to look a little bit more difficult when you add the requirement that they work offline. So trying to do any of these things becomes harder. And in fact, I'd go as far as to say that trying to make your app work offline makes almost everything harder. So it's very difficult then to retrofit offline to an existing web application. It really has to be baked in from the very start. And adding it as a requirement at the very start makes your build harder. Which isn't to say, obviously, that you shouldn't do it. And if you do want to do it, the first thing you'll need is offline storage. You need to be able to store your application state, and all of your application's active data in the browser so that we can create pages and populate those pages, navigate links without having to contact our server. So we need some client-side storage options. Now, these are a set of technologies which have been designed independently, but you have to use them together. And I like to think of them as a bit of a dysfunctional family, because they don't like to work together very well. Some of them don't even like to work very well on their own. So I like to model them a little bit like this. Cookies is like the granddad of the family. Can't remember very much. What he does remember insists on telling everyone that will listen. Local storage is a very simple key value store. Not very organized, but knows exactly where everything is and can retrieve it very quickly. IndexedDB is a much larger data store, can remember loads and loads of stuff, and can remember really complex information, but sometimes takes a long time to find it. And App Cache is, well, I won't make the technical comparison, but App Cache is like the child that you are really proud of, you just wish they wouldn't be so annoying all of the time. So I'm going to go into this, make these comparisons a little more practical in a second. But before we get to the technical problems, we also have regulatory issues. Now, most of us live in the EU, and we're probably getting quite sick of this sort of thing. And this is one of my favorite examples of these cookie notices that you see, particularly on British websites. I don't know whether the same is true in Finland. The Daily Mash has perfectly captured the user sentiment here by saying, we've updated our privacy policy, not that you care. You can read it or click to get rid of this annoying message and carry on as before. And the button says whatever. And I think that exactly matches the sentiment of the user when they see that message. So they've done their user experience research there. The problem with this legislation that forces us to do this kind of thing is that it doesn't actually mention cookies explicitly anywhere. So it could equally apply to local storage, to IndexedDB, to App Cache, any kind of technology that allows us to store personally identifiable data, tracking data on the device. So as we start to build offline apps that store ever more data on the device, this becomes even more of a problem. But let's say you get past the legal issues, then the technical issues start rearing their head immediately, and some of them are really quite bad. So this is Firefox, for example, prompting the user for permission to use offline storage, because Firefox is quite good at asking the user for consent for things. What it's not good at is coordinating those permission prompts so that they don't appear on top of one another. And it's also not very good at making them look consistently styled. So this is an example where one of my colleagues created a very simple test case where we ask for access to App Cache and IndexedDB at the same time. The prompts that Firefox produces are extremely badly designed because they differ in ways we don't want them to differ, and they're the same in ways that we don't want them to be the same. For example, the text, although you can't see it because the one is on top of the other, the text of the bar is exactly the same as the text of the pop-up. So it's actually not possible, even for a developer, to tell which of these is App Cache and which of these is IndexedDB. And what behavior should the user expect if they press allow in one and deny in the other? That behavior is completely undefined and makes this user experience pretty terrible. So looking past all of that kind of stuff, let's assume the user gives consent. Then which technology should we use to store our data? the obvious answer is, well, you should use the one that's most appropriate for the data you want to store. We should use IndexedDB for structured data. We should use app cache for request caching. We should use local storage for settings, preferences, and cookies for authentication tokens. But that would assume that all of these backends have the same comparable latency and same comparable capacity. And that isn't true. So here's a JS perf test that I set up, testing, reading and writing the word test to each of these data stores. And I could do that 30,000 times a second in local storage and 300 times a second in IndexedDB. So even if the kind of data I want to store would be most appropriately stored in IndexedDB, I'm going to store it in local storage anyway, because it will make my application faster. And that means that I'm actually sacrificing potential technical elegance in favor of performance. And that's a trade-off that's very easy to make from a business perspective. So you might be thinking, well, you know, this sounds pretty awful, and it is. But ultimately, you can store stuff offline. These technologies do work to some degree, and they can give you the basic functionality that you need. So having stored stuff offline, you then need to use them. You need to deal with the use case of having an empty browser, a URL, and needing to load that URL with no internet connection. So this is where bootstrapping comes in. And I'm going to introduce bootstrapping by talking a little bit about the way that web pages are constructed. Because when we first started building web pages, they were mostly just content, which is good because the internet connections weren't very good, and we needed to keep our pages really small. But then we realized we couldn't make any money out of that, so we added some advertising. And the advertising code that delivered the advertising into the page was the same pretty much on every page. So we started to get common elements between one page and the next, which nevertheless needed to be loaded with every page. But then we had business analysts and user experience consultants and various people who thought it would be a good idea to create more links between pages to improve the interconnectedness of the web and improve engagement. So we added a lot more stuff to our pages. And the result of this is that now 95% of the content of this page is the same from one page to the next. Even really long articles, the content is still the tiny minority of markup on the page. So recognizing this problem, we realized we needed to do something about it and make our pages feel snappier and more interactive. So to do this, JavaScript seemed the obvious solution. Let's put some code on the page that will enable things to happen without the page needing to be reloaded. So we'll just add some more stuff to make that happen. So the pages get even bigger, and now 99% or even less, 99% or even more of the content is the same from one page to the next. So when we go to make this page work offline, the obvious thing is we can't just store all our pages because we don't have enough space. And it's a really inefficient use of the space we do have to store all of this content which is replicated from one page to the next. So we need to store just the bit in the middle. And to do that, we need to be able to construct those pages on the client side. So bootstrapping is about keeping your content clean, delivering pages that just contain the content itself, and then building all of the other stuff afterwards. That also means that we can start our kind of enhanced experience where we can navigate around the app without reloading the page from any URL. We can handle errors. We can load only those modules that we actually need on that page. And that can depend on variables that change on the client side. So for example, say our page supports swiping and pinching. There's going to be a JavaScript library that will enable that. We only need to load that JavaScript library if the device supports touch. So there's no point in loading that JavaScript module if our page is being viewed on a device that doesn't support touch. And we can also use the bootstrapping process to mollify the tendencies of some of these technologies that we don't like very much. And I'll get onto that in a second. So here's an illustration of the kind of thing I'm talking about. When you make your initial page load for a particular article, now let's assume we have a newspaper use case, so there's 5 to 10 million individual URLs referencing articles that have been written over a very long period of time. There's no way we could possibly store all of those URLs offline, so the browser can't possibly know whether this URL is a real article or not, unless we actually send that request to the server. So if we're able to contact the server will send back just the content of that article and allow the rest of the page to be built up on the client. If we're not online, then we can instead serve an empty page from the app cache. And then we can try and fill in the article content from somewhere else. So we can then add those extra modules, the extra CSS, JavaScript, and HTML that will enable us to build a more advanced page and take advantage of a larger amount of screen real estate if we have it available. We can read the authentication token if there's one in the cookies, and we can pull in additional content. Say we're offline and we haven't actually been able to load the article from the network. At this point, we could look to IndexedDB or WebSQL to try and load that article from a local database. So what I'm trying to illustrate here is that we're using all of these technologies in unison to create an offline app. So the first of these requests, the one that delivers the initial payload, if you're not online, the only place that can come from is the app cache. So we need to talk about the app cache. Conceptually, the app cache is very simple. You create a list of resources that you would like to make available offline. The browser then downloads all of those resources and stores them, and forevermore, those resources will now come from the app cache and not from the server. There are a few interesting additional features, like the fallback section here lists prefixes. So this deals with your 5 million URLs scenario. Rather than listing them all in your app cache and making it impossible to download the whole thing, you list just a prefix, and you say any URL that starts with this prefix, load this resource, and you just store one single resource to do that. So that resource clearly will not contain the content of that article, but it will contain an empty bootstrapper that we can use to turn into that article page. And finally, there's a network section, which is the first gotcha of app cache development, because the network section lists all the URLs that you want to allow to access the network. So if you don't put anything in that section, then your app, by virtue of having this manifest, becomes immediately an offline-only application. And the browser will then never request any URLs from your server ever again, other than the manifest itself, thankfully, because you can then correct the problem. Unless you put a really long cache expiry time on your manifest, then you're just simply screwed. But that's by no means the worst problem of app cache. This is my favorite one. Any page on which you reference a manifest, that page will also get cached in the app cache, even if you didn't list it in your manifest. And the problem with that is that, let's say you reference a manifest from the homepage of your news site, say. News organizations tend to publish news on a fairly regular basis. So if the homepage of our news site gets pulled into the app cache and is then forevermore served from the app cache, we will never publish any more news. And that's a problem. Because any page that's pulled into the app cache will then be used from the cache in preference to fetching a fresh copy from the network. Even when we're online and even when that content has expired in the cache, you'll still get the cached copy. So in practice, what does this mean? Well, we can't reference a manifest file from our dynamic content pages. And because the vast majority of our pages are dynamic, or at least we want to be able to update them, we can't do this. So if we can't put a manifest attribute on our HTML tags, how do we reference a manifest? There's a chicken and egg problem here. So this leads to the second worst hack that I will introduce you to today, which is the idea that you just put your manifest tag on a manifest attribute, on one page of your site, and you then include that page in a hidden iframe on every other page of your site. Now that page doesn't have to be a real page. It can be a sort of sacrificial app cache loader page, a page that you don't mind getting pulled into your app cache because it doesn't contain any content that you want to update. Nevertheless, it does mean that for every page load, you're making a secondary page load in order to boot up your app cache. And I did say that was the second worst hack, so we'll get to the worst one in a minute. There are some other problems as well. App cache is obviously something that people are most interested in dealing with on WebKit because the kinds of platforms where we care about offline access tend to be running WebKit browsers. But Internet Explorer and Firefox are becoming increasingly important in this space, Internet Explorer being the default browser on Windows 8 tablets, and Firefox on Firefox OS, and also a fairly important secondary browser on platforms where WebKit is the primary. So Internet Explorer won't populate the app cache at all unless the manifest is ordinarily cacheable, in that it would be cacheable in the browser, in the standard browser cache. And Firefox won't store any resource in the app cache if it's served with a no-store cache control directive. So we can deal with these. For Internet Explorer, we can set a 1-second cache time and put the private cache control directive in. That means that the manifest won't be cached by any intermediate public proxies. It will only be cached by the browser itself, and only for the 1 second required to convince Internet Explorer to actually use the manifest. And for Firefox, we can just avoid using the no store directive, which is reasonably easy to do. So here's another problem. When we update our manifest, let's say we add a file to the app cache or we remove a file from it, we can't simply do that single operation. The browser will discard everything in the app cache and re-download every single file. That's because the app cache is atomic. It's an all-or-nothing cache. You can't simply add a file to it or remove a file from it. So the only way we can resolve this problem is to put far future cache headers on our content and to give them all unique version query strings. So when you build your manifest, you can put a version query parameter on each URL. When you serve these resources from your server, set an expiry time years in the future, and that will ensure that the browser cache holds on to those resources as well as the app cache. So when you then issue a new manifest, the app cache will wipe everything that it previously downloaded, and it will re-download everything. But almost all of those resources will be in the normal browser cache, the HTTP cache. So they'll be served from the browser cache to the app cache, and will repopulate the app cache without a network request. And this is another gotcha of app cache development. App cache isn't a replacement for the browser cache. It's entirely in addition to it. So it's quite possible for the app cache to purge itself of content, request new content, have that content populate the cache without ever making a network request. And here's a final one. If we're on a really slow network, so not a broken network, the device thinks it's online, but it doesn't have a workable network connection, and we go to one of those URLs which we haven't explicitly cached, but matches one of our fallback rules, we have to wait for the device to try to load the full URL before it will use the fallback. And we can't control how long that timeout is. And the timeout will vary from one device to another. So the only consistent thing between those timeouts is it is typically longer than the user is prepared to wait. As a result, the app appears to be broken. And the only way we can deal with this at the moment is to ensure that the URL the user is loading is one that we have explicitly cached. And for that reason, we currently include our home page explicitly in our app cache, simply because we want to avoid this problem. And as a result of that, we can't put any dynamic content on our home page. So this is a pretty serious problem. Another way you can solve it, if you're Google and you have a browser that you're building as well as a website for which you want to solve the problem, you can simply add an extra extension to app cache. And they've done this, and they call it the intercept namespace. So as well as fallback, you can list an intercept section in your manifest, and for entries in that section of the manifest, if the request matches the pattern, it will load the resource without recourse to the network. So even if you're online and you have a really good connection, that resource will always be loaded from the app cache regardless. And that essentially solves that problem. But this is only available in Chrome and not supported in any other browser, so effectively useless for most sites that want the interoperability. Another way we can try and solve this problem, a bit harder, is to try and achieve a solution that goes into the spec and is then adopted by all the browser manufacturers, and that's the purpose of the Fixing Application Cache Community Group at W3C, which I co-chair. And I would encourage anyone who's interested in this topic to get involved, particularly because application cache really needs to be fixed. Here are some ideas for fixing it. What we could do is separate the cache from the routing. So the purpose of fallback and the purpose of this new intercept that Google came up with is effectively to act as a front-end front controller. It's a way of looking at the URL and working out what we want to actually serve. Now, that's not actually a caching thing. That's nothing to do with caching. That's routing. So we should separate, maybe, the idea of routing from the idea of caching. And there's actually a spec bug very recently raised by Ian Hickson on the W3 Bugzilla tracker that discusses that solutions to that problem. We could have more granular atomicity. What if I'm publishing a weekly magazine and I want to download an issue? I don't want to get rid of all my other issues and re-download them just because I've published a new issue. I'd like that issue to be atomic, but I don't want atomicity over the whole cache. So we need more granular atomicity. And we don't currently have an effective way of interacting with the application cache from JavaScript. I can't read the contents of the cache from JavaScript, and that's very limiting. So we ought to have some kind of API to interact in a more effective way with the app cache. And the spec ought to do something about quotas, because a browser vendor could implement a hard limit of 5 megabytes on the amount of stuff you can put in app cache, and that would be perfectly in compliance with the spec, but it would be useless for most applications like ours, where we'd like to give you enough content that you could read it on a plane, for example. And if you've got 5 hours on a plane, you're going to consume more than 5 megabytes of content. So whilst we're waiting for all of those problems to be fixed, we need to use app cache in a very specific way. So what we use it for is things like fonts, sprites, the splash image, the application icon, and our fallback page. What we don't use it for is any of our other HTML pages, our CSS or our JavaScript, most of which we store in local storage. Because in local storage we can update individual resources independently, and we have much finer grained control. And I was talking about quota a moment ago and how we need more space. And until we get more space, we need to optimize the space that we already have. Because actually, the amount of space we have is really tiny. Now, this graph and this chart is actually a little bit out of date. iOS 6 has increased the app cache maximum to 25 meg and has removed the limit on IndexedDB, which is brilliant. But for other devices, we're still dealing with some very small quota limits. And these numbers that you see here, you might think of mapping onto characters by thinking, well, I write predominantly English content, or at least content that is mostly ASCII compatible. So in UTF-8, you would hope that 20 bytes of text, 20 characters of text would consume 20 bytes of memory. And you would be wrong. Because JavaScript encodes its strings in UTF-16, which actually reserves exactly 2 bytes per character. So a 20-character string will actually consume 40 bytes of storage. Now, if you've only got 10 megabytes of storage available, you've suddenly cut that in half. Which leads me to the number one hack of this presentation, which is to, yes, it's kind of like this. That joke didn't work because I forgot that I was going to make it. So it's kind of like people parking like this, and nobody likes people parking like this. So we need to fix this problem. So this is how we fix the problem. We take our content, we encode it in ASCII, so anything that's a non-ASCII character will HTML encode. And then we'll take each pair of ASCII characters and remove the character boundary and convince the browser that that is one single UTF-16 character. And yes, no, seriously, we do this. And the result is that you take every six character word becomes a 3-character word. Obviously, the result doesn't make any sense, but it's exactly the same bit stream. And that's really important to realize. We're not actually changing any bits. We're just simply changing the character set. We're saying, actually, this same binary data is half the number of characters. Please interpret it like that. So instead of padding our strings with millions of null bytes, JavaScript just happily stores exactly what we send it. Unfortunately, DevTools makes it look a bit like this. So debugging becomes slightly more difficult. But the actual algorithm for doing it is very simple. That is it. That's the entire code. I haven't simplified that at all. That's exactly what we run to convert the ASCII to UTF-16. And I know what you're thinking. This is too simple. We need to make this more complicated. So what we realized was that actually a lot of the data we store offline is base 64. The reason being that a lot of the data is images. And there is no mechanism at the moment for storing binary data reliably across a lot of browsers. So we have to represent that image data in text. The only way we can do that is to convert the images to a base 64 encoding. Base 64 uses 64 characters. 64 possibilities only requires 6 bits to represent. 6 bits is actually a sub-byte encoding, but 6 divides into 48, so we should be able to get 8 base 64 characters into 3 UTF-16 characters, and we do that like this. So take your original text. Because the original base 64 characters are not actually the code points 0 to 63, we have to map them onto the code points 0 to 63. Then take that resulting binary data and take every group of 16 bits and convince the browser that is one character. Martin is looking at me like I'm completely deranged. And you know, why stop there? I mean, we actually like we actually like UTF-8, so why don't we use UTF-8? We could take a UTF-8, which is a variable length encoding, and encode that as UTF-16. Now, the main problem with this is that it's not a simple mathematical mapping anymore. It's now a matter of understanding how the encoding actually works in order to make the mapping from UTF-8 to UTF-16. Because JavaScript, when we ask it for the code point for an individual letter, will give us the UTF-16 one, not the UTF-8 one. So we have to calculate what the UTF-8 one is. As a result, we tried to do this, and it took about 100 times as long per character as doing the ASCII conversion. So we stuck with ASCII. But, you know, that's one way of doing it. And the final thing I'll talk about is connection state, or knowing whether you are online or not. Because when you're building an offline app, or an app that has some functionality when you're offline, you have to deal with the user experience that you want to offer the user when they're in that state. Because certain things won't work, and you need to manage the user frustration that will inevitably result from that. So HTML5 has opened up access to some additional data that we can query within the browser to find out some information about our connection. And it's called window.navigator.online. And I'd like to ask you this question. If the value of window.navigator.online is true, what does that mean? Now, according to the spec doc, and I'm almost literally quoting this, it means the device might be online. So this is a fairly badly designed API for 2 reasons, in my opinion. One is that somebody decided that online was 2 words, and so capitalized the L. We're stuck with that, I'm afraid. You have to do that. And secondly, probably the same person decided that true and might were good bedfellows. I probably have called it window.navigator.offline, which is true when we know we're offline, and false when we don't know. Actually, what we get is true when we have no idea, and false when we know we're offline. So provided you understand that that is what it's telling you, because it's not intuitive, then you can create user experiences that don't lead the user astray. So we also build the Economist's HTML5 app, and this is an example of how we use that information. So whilst the issue is downloading, we can give you a nice, solid progress indicator that's marching across the screen quite happily. When we stop receiving data for a certain period of time, even if navigator.online is still true, will show a different style of progress indicator to show that it's now struggling. And something might be going wrong, but we're still trying. And then at some point, a further timeout will occur, and we will give up. And we might do this despite the fact that window.navigator.online is still true. So in this state, we'll show a grayed out progress indicator, and there's two really important aspects of this user experience that manage user frustration, because we have not delivered what the user wanted. What we have done is left the progress indicator at the point it got to show you that we acknowledge we got to this point, it wasn't time wasted, and when we get a signal back, we'll be able to carry on from where we left off. And second, we give you a button to click or to tap that tells us to try again. Because we may know better than you do when we have a signal, but it will make you feel better that you haven't got to a dead end. And it is actually perfectly conceivable that you'll know before the device does when it's a good opportunity to try again. So managing the way that we use the information that's available about the network state is really important to delivering a user experience that isn't frustrating for the end user. And there's actually a spec that's going through a lot of discussion at the moment on mailing lists that will provide additional information. It's called the Net Info API. There's a lot of controversy surrounding it because a lot of people, I think, us included, really think that it's of limited use. It will tell you things like whether you're connected to Wi-Fi or 3G. So that, on the surface, sounds like a really useful thing to know, but you might be connected to Wi-Fi provided by someone else's iPhone that's sharing their personal hotspot with you, and they're then connected by 3G. And the Net Info API wouldn't be able to tell you that. Or you might be connected to Wi-Fi, but you're on a captive portal, a Wi-Fi network that you haven't logged into yet, you haven't paid for access to. So the device thinks it's connected, it thinks it has a good, strong Wi-Fi signal, but actually nothing will work. So we need to bear that in mind and design our interfaces accordingly. I'll finish with just telling you a little bit about some of the open source releases we've made that you might want to make use of in your own projects. So, we've done this stuff already, you can use ours. We created an app called, a library called Column Flow that enables you to lay out content very much like a magazine in very tightly, horizontally paginated columns. And it's pretty advanced in that it allows you to have things that span columns, inserts that go at fixed locations. It deals with things like orphans and follow-on titles and all kinds of print typography things that are important to people who print newspapers. And it's been forked by the Telegraph and Baidu, so there's quite a lot of interest behind this. We also created FT Scroller, which is a momentum scrolling library, very much like Scrollability or iScroll or Zynga Scroller. We created one of our own because we felt that we could do better on performance, and we also wanted IE10 compatibility. So this, as far as we're aware, is still the only momentum scrolling library in JavaScript that works in IE10. And finally, we also created FT FastClick, dropping this library into any application, any web application that you're accessing on a touchscreen device will improve the responsiveness by about 300 milliseconds. So any tap will turn into a click about 300 milliseconds faster. And none of those have anything to do with offline, but you should check them out anyway. So what are we advocating? We would like to see fewer individual solutions and more adaptive solutions. Don't build a mobile site and a desktop site or a tablet site or, even worse, a BlackBerry 10 site and a Windows 8 site and an iOS site and an Android site. Build one and make it adapt. Use web technologies because they're designed to do exactly this, particularly in publishing, because the web was actually designed for a publishing use case. And if it can't achieve that well enough, that's a pretty serious indictment of the web. And remember, HTML5 is not a mobile solution. It's just a way of making better websites. And that's probably something that we understand fairly well, but it's something that we need to be continually reiterating to our stakeholders in our businesses, that HTML5 is not an alternative to the native app route. And responsiveness is not about multiple static designs. Your design team, I've seen design teams come up with 3 or 4 Photoshop designs for a site, hand them over to developers and say, that's your responsive site. You just need to go from this one to this one to this one. But actually, that's kind of missing the point. Responsiveness is about adapting to the environment, not just adapting to one single variable. So we also need to adapt to things like the kind of interface technologies that a touch device was a desktop computer or a laptop. Is this a device which has a mobile connection, an unreliable data signal? How tall is the screen? You know, there's an enormous number of variables that we could feed into this responsiveness equation, and you should keep those in mind. I like to work with designers who can give me a design and say, this is what it will look like under these circumstances, and acknowledge that that is not going to be the same for every user. So I'm more or less finished with a quote from Mr. Tim Berners-Lee, who asked a question to at a conference recently, and he gave the rather loaded answer, don't build native apps, build web apps. Thank you very much.
Thank you.
Anybody got questions?
Yes.
Are you actually using web SQL now that it's being depreciated?
Are we using web SQL now it's been deprecated? Yes, we are. Mainly because there are some platforms that still don't support IndexedDB. So we actually use both. The app has an abstraction layer that allows us to access the database in a back-end agnostic way. And then we'll choose which one to use based on which platform we're on. That's another element of responsiveness, I guess.
Yeah.
Right there.
Hi, thank you for the presentation. I have actually two questions. The first one being, do you use any kind of JavaScript library, like Vanilla.js or jQuery or similar?
We have extracted various elements of jQuery.
Okay.
I think initially we used jQuery's Ajax implementation because that was very robust. I don't know whether we still do, but we use very few elements of open source libraries. We do use some wholesale, but they're very, very small. So we use a few ES5 shims, for example, to provide ES5 support where it doesn't exist. But most of the JavaScript that we write is homegrown.
All right. The second question, we are facing the problem with designers doing exactly what you said. They design for different breaking points. And it's a real challenge for the designers. Do you have any suggestions for tools or similar to make the designs? Because not many designers know HTML and CSS, which would be great if
Sure.
they could just prototype the layout and how it would respond and so on.
I think that's a problem with a number of answers, which some are more pragmatic than others. You could say, well, designers need to learn to code. You could also say, well, produce one design, implement that, and then designers work with developers to modify the design in browser after that point. And that could be a kind of compromise position. And I think there has to be an element of adaptability to it. I think there was a case study by Filament Group about their work with Boston Globe, which is a really good example of responsive design. And they didn't work to a lot of mock-ups, I think. They just had a close cooperation with the designers, and they looked at how the site behaved in certain conditions, and they just modified things. And I think that working like that allows you to visualize and see the effect of a lot of different variables at once, where you really couldn't do that just by building mock-ups, because you would need so many mock-ups that your design team would just faint.
Yeah. I've seen designers take or do their designs in Illustrator, because it's so much faster to work in Illustrator. Right. But they normally do for designs, they might focus on different elements differently depending on, but it's still the best solution I've seen so far.
There is also the option of using like a tool to create actual real web content. So they could use some online tool that would allow them to build the website without writing HTML, like a sort of WYSIWYG web builder tool. And in that way, you can kind of bridge the gap between design and development a little bit. And I know there are a number of those kind of tools available that people have started to experiment with.
Yeah, I actually saw Jetstrap, which uses Bootstrap, which I think it's a great project for people who don't code.
Yes.
But I still rather do my designs in HTML5 and JavaScript. So.
Sure.
Yeah, but thanks for the answers. Thanks.
Right.
There's one more question up here. You mentioned you're working or actually chairing the group for fixing the app cache.
Where are you? Sorry.
I'm up here.
Oh, hi.
And I was wondering who are the other members, and would you say your position is more like General Custer or Sitting Bull? I mean, have you had any wins, or is there any progress happening?
So the other chair is Toby Langle, who is Facebook's W3C rep, and there's not a lot of activity going on in the group at the moment. Toby and I are both going to be at an offline meeting of, I think, a dozen or so people at Google on the 8th of February, and I think we'll be making some progress on possible proposals there. But there's a lot of activity going on in the W3C spec groups, bug tracker, and there's some interesting discussions there, and that's also going back to the community group as well. So it is having some positive effect. It's not as quick as we had hoped, but I think these things rarely are. As for our leadership style, I'm not sure I'd like to comment on that.
Yeah.
I'll let other people make a decision about that.
So let's take one more question, and we'll head to a break. And Andrew, I guess you can stay here for a couple of minutes to answer some more, but so we can move ahead with the agenda. So please.
Yeah, Vitaly from Conmil. I was just wondering that...
Sorry, I keep thinking this guy's going to ask a question.
Yeah, we're up here.
Where are you? Oh, there you are.
Yeah, the previous speaker was talking about the Internet of Things and talking about how Cisco is projecting that by 2020 there's going to be 40 billion connected devices, and you yourself were talking about how challenging, especially with the state of APIs and the frameworks, is on how difficult it is to make offline viewing. So basically my question is, like, do you see a future and a relevance for offline viewing capabilities?
Oh yes, certainly. I mean, I don't think we are going to see the reliability of mobile connections match that of wired desktop connections anytime soon. There's always going to be situations in which you simply don't have connectivity, and we've always had, as I said from the beginning, we have a newsreading client that works in that situation. If we're going to deprecate that client, i.e. newsprint, we need a solution that works offline. I think there's no question about that. Now, there are a number of technologies that will deliver that, and I personally think that the web is the best way forward.
Right. All right, let's take the last one from
here. Just a short comment, really, to you. I think Adobe is coming out with a product called Adobe Reflow, something like that, which looks like it's going to be some kind of Photoshop for the responsive web. As far as I know, it's not meant to produce code, but it's really for designers so they can...
Yes, I think that's part of the
designs.
Adobe Edge suite, which is looking like a very promising set of tools for designers and developers to collaborate on this kind of stuff.
All right. Right. Thank you, Andrew.